Okay, so we talked about dimensional analysis yesterday. Now we're going to talk about our metric system. So metric conversions can be done in two different ways. So I've taught it in two different ways in different places. I've discussed it with all the other science teachers, and we believe that this is actually the better way of doing it, because then we can stick with our dimensional analysis method of conversions. So what I want to do is I want to teach you how to use the ladder instead of using the staircase. So the ladder basically gives you what it is. So instead of, so our one category, and then we have our tenths, our thousandths, our hundredths, thousandths, 10,000th, and we keep on going from there. And then we have our tens, hundreds, thousands, and we keep going further up if need be. So with that being said, I want to make sure that you understand that there are 10 decagrams, there are 10 grams in 1 decagram. There are 100 hectograms and 100 hectograms. There are 100 grams in 1 hectogram, and there's 1,000 grams in 1 kilogram. So we can go from that point, understanding that we're going to use dimensional analysis to do this. So in this particular case, we are taking our 302 millimeters, and we are going to convert that into our meters. With that being said, if we look at our milli, it says to the -3. That means there are 1,000 milligrams in 1,000 millimeters in 1 meter. In 1 meter. And remember, we want to be able to cross these out to find our correct answer. So in this case, there are 0.302 meters in 1,000, or in 302 millimeters. Okay, so let's do another one. So I'm going to take my 5 milliliters, my given, and I want to get that to my kiloliters. So we're going from here to here. So we can see, if we want to make this multiple steps, because we know which one each one is, so we're going to do that. We're going to make this one kiloliters. So we know that there are 1,000 milliliters in 1 liter. So we also know there are 1,000 liters in 1 kiloliter. So that means that we have to divide this. So in order to best make it the easiest possible way, and let me wipe this out real quick to make it look prettier. So we want to find out how to get this to the particular spot. And if we're using sig figs, we have to make this a 1 significant digit. So we see that we're dividing by 1, 2, 3 in the first one, so that's going to make it 0.005, because we move our decimal place over 3 spaces. And then we see we divide by 1,000 again. So that means we need to move it over even further. So this isn't anywhere near. So it's 0.00005 kiloliters. And this is a correct sig fig because there's only one. You see what we're doing there? So see 1, 2, 3, 4, 5, 6 because we're moving it over 1, 2, 3, 4, 5, 6. So there are 0.00005 kiloliters in 5 milliliters. That also means that we can do 5 times 10 to the -6, because 1, 2, 3, 4, 5, 6 kiloliters. Either one is fine. Okay, let's do one of the extended thinking problems together, because you're going to have to do those anyways. You do not have to do the honors section, but you do have to do these. So let's convert 2.05 times 10 to the 5th second. Bless me. Into years. So we know that there are 60 seconds in 1 minute. If you know the movie Rent, you know how many minutes are in a year, but we're going to go further into our dimensional analysis. So we know that there are 60 minutes in 1 hour, and we know that there are 24 hours in 1 day. Now, if we go to that point, we also know there are 365. Oh, wrong side. Remember, gotta cancel them out. 365 days in 1 year. So that gives us our answer of how many days are in a year. So we take our 2.05 times 10 to the 5th. Oh, I can do that better. 2.05 times 10. Okay, that didn't work at all either. Alright, 2.05. Oh, 2.05 times 10 to the 5th divided by 60 divided by 60. Okay, so I can't figure out. I don't know why I'm not able to figure it out right now. But anyways, we'll just go out. So 1, 2, 3, 4, 5 divided by 60 divided by 60 divided by 24 divided by 365. So our answer is 0.0065. So 0.0065 years is our answer. Now we have a problem because we have to do sig figs, and our original sig fig was 3. So that means we just add a 0 to our answer, and now we have the correct amount of sig figs. Okay. All right. So now let's go the opposite direction. Let's go from years, 50 years, to seconds. And we know it's going to take that long because look at what the top one did. So we know that there are 365 days in 1 year. We know that there are 24 hours in 1 day. We know that there are 60 minutes in 1 hour, and we know there are 60 seconds in 1 minute. So, should be a simple answer, right? Oh, but we have to put it in scientific notation. It even says it this time. So 50 times 365 times 24 times 60 times 60 equals 157680000. So we need to put this in scientific notation. So we move our decimal spot over 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 1.5768 times 10 to the 9th seconds. But if we look at this, if we do sig figs, 50 only has 1. So that means we have to do a lot of rounding. Now, here's our problem. Remember when we talked about accuracy and precision? Well, sig figs are not necessarily always accurate, because if we take this down to sig figs, we got to round it up to 2, and that doesn't explain a lot of the times in there. Because are there really this many seconds in a year, in 50 years? No. But that's what sig figs says there is. So in this particular case, it'd be way more accurate to go with our answer, or you can just round it to 0.58 second times 10 to the 9th seconds. Okay? So if you're having trouble with this is pretty simple. We'll do standard, and we'll go from standard to metric, and from metric to standard, and then we will do density next week. So good luck. I hope you are figuring this out pretty well.